Hello and welcome to this AimHi Live. On AimHi you can ask questions whenever you want. This is interactive all the way through, so basically, yeah, as soon as you hit any problems or you want to ask me a question or whatever, just like throw it into the chat. Anyway, so today we're going to do high school maths and we're going to do trigonometry and Pythagoras' theorem. Does anyone know what this building is? This building was built almost 1,500 years ago. Oliver's saying, is it a mosque? Which is an interesting question because actually it is not a mosque and it was not ever built to be a mosque, but for almost all of its life it's not been a mosque, but very, very, very recently it was turned back into a mosque. And it was quite controversial for various reasons because it's basically this, so I'll tell you what it is. This building is called the Hagia Sofia. It is, as I said, one of the most important buildings in the whole world. If you're just joining, then yes, this has nothing to do with trigonometry or Pythagoras, or does it? But I'm just explaining a bit about the Hagia Sophia. So yeah, the Hagia Sophia is in Istanbul, which used to be called Constantinople. Now, Istanbul has been a country that has kind of flipped backwards and forwards over the history of the world between different religions. The country has long kind of been home to many, many different religious groups. And so, for the last 100 years or so, the rulers of the country decided that this building, rather than either being a mosque or being a cathedral or whatever, would just be a museum. And they thought, let's just make this a museum because then no one can argue over it. But very recently, it was turned back into a mosque, which has upset a lot of religious groups who think that it shouldn't become one or the other. Anyway, the reason why I wanted to tell you about this building is because it's actually got something to do with trigonometry and Pythagoras. Look at this building, look at how complicated it looks, especially considering it's so old. When this building was built, it stood as the largest enclosed space built by humans for about 1,000 years. How long do you guys reckon it took to build this? So to build this building took about 7 or 8 years, which, considering this was 1,500 years ago, is crazy. It's absolutely crazy that they built it so fast. And the way that they did it was by essentially stealing loads of bits of buildings from the ancient world, like pillars from Ephesus and doors from different temples and stuff like that. And they just grabbed it all and pulled it all together and they put the thing up as quickly as they possibly could. And the only way that they managed to build something so complicated and so huge and so able to sustain itself and not collapse was because of an incredible understanding of trigonometry and Pythagoras' theorem. Loads of complicated shapes, but ultimately, without a good understanding of triangles, none of this would have worked. The dome that they built at the top remained a huge mystery. I think maybe still remains a mystery of how they did it, because it's so thick. It's not only so huge and impressive, but it's also so thin that when it was full of candles and there was not many other light sources, ships floating in the river could see the dome glowing. And they could see the dome glowing from really far away. This building is incredible, and if you ever get the chance to go and see it, then you must, because it's one of the most incredible buildings in the world. It's had so many cultures in it, so many different religions, so many different historical things happening within this building and around it. It's one of the most amazing places in the world. Nobody could have built stuff like this if they didn't have a decent understanding of triangles, and that's what we're going to do today. So triangles is something that I think in maths is often taught in a bit of an abstract way. Oh, we're going to learn these rules about triangles and then that's it. And I really wanted to introduce you to something that was achieved with this maths of triangles. Building something like this in 7 or 8 years is insane, 1,500 years ago, and yet they did it because of their skill with triangles. Now, when you get really good with triangles, you will find that completely unlocks the world of all kinds of things in terms of engineering, building things, just how basic problems work in the home and in normal life. Triangles is probably the most interesting and useful thing that you ever learn in maths. Anyway, so there was this guy called Pythagoras who came up with this amazing piece of maths which completely transformed people's ability to build things. And he realized that if you take any triangle that has a right angle in it, like this one, so by a right angle we mean 90 degrees, so a corner like this, then if you label a triangle like this with an A and a B on the two shorter sides, and it doesn't matter which way around you label these, the A doesn't have to be the shortest and the B doesn't have to be the second, it doesn't matter. Because A and B are the two shorter sides, and then C is the side opposite the right angle. Does anyone know what the kind of posh mathsy word is for this long line opposite the right angle? But anyway, he came up with this amazing theory which just said this. It said A squared plus B squared equals C squared. And yes, brilliant. Alstone and Karina have both got that. So the word for this long side is the hypotenuse. So the relationship that Pythagoras came up with was A squared plus B squared equals C squared. So let's have a go at doing this. Let's say this side is 3 long and this side is 4 long. Can anyone work out how long this side will be? So A is 4, so we're going to do 4 squared, plus B is 3, so let's do 3 squared, and that's going to equal C squared that we don't know. So 4 squared is 16, 3 squared is 9, so 16 plus 9 equals C squared. 16 add 9 is 25 equals C squared, so C is going to be 5. Now, the square root of 25 is also minus 5, but you can't have a side that's minus long, so we just ignore the minus 1 and we're just going to do that. Cool, well done everyone. I can see that everyone got that right. Great. Right, let's give you a harder one. Now, you might need a calculator for this one, because this one might go a bit decimally. Right, so let's say now you've got a hypotenuse which is 10 long, and let's say that this side here is 4 long. How long will this side have to be? So A squared plus B squared equals C squared. We don't know what A is. We know that B is 4, so 4 squared is 16. And we know that C is 10. So 10 squared equals 100. So 100 take away 16 is going to give us 84 equals A squared, which means A equals the square root of 84, which is 9.2 if you do it on your calculator. Exactly. Nice work, Karina. That's really good. Okay, so let's say that B is going to be 2, and let's say that A is going to be 5. Then what will C be? Oh, yeah, you both got 5.4. That was so quick. Nice. Yes, so C is going to be 5.4. Perfect. Good. Right, let's move on to the next bit of triangles. So next we're going to do Socatoa, and then we're going to do the sine rule, and then we're going to do the area rule, and then we're going to do the cosine rule. And the cosine rule is pretty long and kind of messy, but we'll just go. We'll see if we can get through all of that. Right, so the next triangle relationship is this one called Socatoa. And Socatoa is the most important one other than Pythagoras' theorem. So in order to do Socatoa, we need to learn a way of labeling right-angled triangles that isn't the same as Pythagoras' A, B, C, because that isn't quite enough to make this work. So what we do is we take a right-angled triangle, and in this right-angled triangle, we're going to label one angle, and we're going to think of that as like the angle of interest. So this is the angle that we're interested in. So let's make it this one. And we're going to use this Greek symbol, theta, to represent the angle. So here, theta looks like it's about, I don't know, 60 degrees or something. So theta is just the symbol that we use in maths to represent the angle. If you want to see what I'm saying when I say theta, it's like this. Theta. But theta just means the angle that we are looking at here. Right, so once you know the angle of interest, now one of the sides of this triangle is going to be called the hypotenuse. So Karina and Alistone, I think someone else already said that this was the hypotenuse here. So this is the hypotenuse because this is the long side. Now these other two sides, we're going to call one of them opposite and one of them adjacent. And we label them based on where the angle is. So if the angle is here, then opposite the angle is this line. This is the line that is opposite the angle. So this side we're going to call O for opposite. And this side here is next to the angle. So this side we're going to call A for adjacent. So adjacent, next to the angle. O, opposite the angle. H is the hypotenuse, that's the long side. Okay, so that's how we label up triangles. If you just want a really quick go at doing it by yourself, let's just take this triangle here. So if this is a right angle triangle and this is your angle theta, then what will side 1 be called? What will side 2 be called? And what will side 3 be called? Great, so 1 is going to be the hypotenuse because that's the long side. 2 is going to be the opposite because it's opposite the angle. And 3 is going to be adjacent because it's next to the angle. Perfect. Okay, great. So that's the standard way of labeling a triangle. Now, Socatoa is the way of remembering how to write out all these equations. Okay, so you might have already seen on your calculator these sine, cos, and tan buttons if you haven't already. Some of you will have already been using them quite a lot, but for those of you who haven't, this is the way the relationships get laid out. So sine opposite hypotenuse. So we write it like this. Sine of the angle equals the opposite over the hypotenuse. So notice how this goes. S-O-H. Sine of the angle is the opposite over the hypotenuse. Now, CAH is exactly the same, but this time with cos. So cos of the angle equals the adjacent over the hypotenuse. Cos of the angle equals the adjacent over the hypotenuse. And then finally, TOA is tan of theta equals opposite over the adjacent. So the tan of the angle, so if you type into your calculator tan and then the angle, then that will equal the length of the opposite over the length of the adjacent. So SOH and then CAH and then TOA. So this is something that is really worth writing out a few times until it's stuck in your head, because you are going to be using these things so many times. Okay, so let's have a go at using them. Let's say you've got a triangle like this, and the angle here is 42 degrees, and you know that this side is 8 meters long. Then how long is this side? Yeah, so if we're trying to find out this one, then the first thing to look at is what sides are we dealing with here? So we're dealing with the hypotenuse, that's the long side, and we're also dealing with the adjacent, so the side next to the angle. So cos of 42 is going to be equal to, cos of the angle is going to be equal to adjacent over hypotenuse. So the adjacent is 8, and the hypotenuse we don't know. So can anyone solve this to figure out what the hypotenuse is going to be? So if you don't have a calculator, you're really going to struggle to do this, because you can need a calculator so that you can rearrange the equation. Okay, so it looks like Karina's got a great answer here. So cos of 42 equals 8 over hypotenuse, which means that if you times both sides by hypotenuse and divide both sides by cos 42, then the hypotenuse is going to be 8 over cos 42. And 10.77 is really good for that. So there's quite a lot of stuff to get through on this one. So I think what I'm going to do with this one is I'm just going to crack on into the different topics, and rather than doing too much practice as we go, I'll just explain how each of the topics works so that we can at least go through those. So next, I want to do the sine rule. So the sine rule is another relationship in maths which now works for any triangle. So for the sine rule, you don't need the triangle to be right-angled. So down here we did Socatoa, and that was for a right-angled triangle with an angle. Here we did Pythagoras' theorem, and that was for a right-angled triangle but with only lengths, and we didn't need to worry about the angles. So Pythagoras' theorem, just for lengths, and Socatoa is for lengths and angles. And the sine rule is now for any triangle. So we don't need to be looking at triangles here that are right angled. This will work for any triangle. And because we're now looking at any triangle, now we need a new system for labeling triangles. And now we're going to go back to something which is a bit more like Pythagoras' way of labeling triangles. So let's have our triangle here. And what we do is we label up the angles. So let's call this angle A, this can be angle B, and this can be angle C. And then what we do is we label the sides, and we label the sides opposite the angles. So if this is angle A, then this side will be side A. And if this is angle B, this side will be side B. And if this is angle C, then this side will be side C. It should be a lowercase c. The sine rule is just like this. The sine rule just says that sine of A over A equals sine of B over B equals sine of C over C. If you have any triangle, so again, this does not have to be a right angle triangle. If you have any triangle and you've got this kind of thing here, where you know that this angle here is, let's say, 54 degrees, and you know that this angle here is, let's say, 21 degrees, and this side length is 18 centimeters, then what will this side length be? So have a go at working that out. So if this is, let's say that this is angle A, then this is side A. And then if this is angle B, then we can label this side B. So let's start filling this in. So sine A, so sine 54, over A, which is 18, equals sine of B, so that's going to be sine 21 over, and then we don't know what B is. So this is the line that we're trying to find. So who can rearrange that to find out what it's going to be? So 18 sine 21 divided by sine 24, which is absolutely perfect. Yeah, maybe Alistair, you don't have a calculator and that's why you've just written it like that. 18 sine 21 divided by sine 54. So the answer is going to be B equals 7.97 centimeters. Okay, so how do you find the area of any triangle? So again, if we label up the triangle in exactly the same way, so angle A, angle B, angle C, and then A, B, C, then any triangle you can find the area of by doing area equals 1/2 of AB sine C. So the area is 1/2 AB sine C. So, and again, this is how you label that triangle. So all we really care about for this is we care about A and B, which are two of the sides. So two sides, and you also need the angle in between them. So if you ever have the angle and the two side lengths either side, then you can work out the area of the triangle. So have a go at doing this one. If you have a triangle that has an angle of 38 degrees, and this is 50 centimeters long, and let's say this is 80 centimeters long, then what is the area of the triangle? So have a go at doing it yourself, and meanwhile I will do a run through as well. So the area is going to equal 1/2 AB sine C. Now, crucially, you can move these labels around as long as you're consistent. As long as if this is angle C, that means this is side length C. And if this is angle A, this means this is side length A. But you can change them as long as you're consistent throughout the entire question. So area equals 1/2 AB sine C. So that's going to be 1/2. And then A and B are going to be the lines either side. So that's going to be 1/2 times 50 times 80. And then times the sine of 38. So that will give you the area of this triangle. which Karina has got spot on, is going to be 1,231.3 centimeters squared. Perfect. Okay, great. Now let's do something that is a mixture of the sine rule and getting the area of any triangle. I think this triangle actually doesn't make sense, but anyway, it doesn't matter because we can still use it to solve the question. So, no, in fact, we absolutely don't need to do it this way. Let's do it this way. I don't need to give you that length. You can definitely do it without that length and it will make sense. Right, okay, so this triangle here, how do we find the area of this triangle? How do you find the area of this triangle? So this is your problem. Find what is the area of this triangle. So the first thing that we want to do is the sine rule. So the sine rule tells us that sine of 41 over 19 is going to be equal to sine of this mystery angle here divided by 31. So sine of 41 over 19 is going to be equal to sine of the mystery angle over 31. So who can work out what that mystery angle is going to be? Okay, so Alison has done this brilliantly. That's exactly the method that we're going to use. So yeah, sine of 41 divided by 19 and then times by 31 will give us that sine of the angle is going to equal 1.07. Oh no, this is why I should not make questions up on the spot while I'm trying to do a lesson. This is not going to work because 31 is too long because we can't possibly complete the triangle with only 19. This question doesn't work. So instead, we need to make this side much longer, otherwise it just won't work out. So let's make this side much longer. Let's make this side 28 long instead. So I've completely messed up this question by not preparing it in advance. But anyway, let's have another go. So if we use the sine length of 28 instead, then it's going to be sine 41 divided by 28 and then times 31 equals, so sine of the angle is going to be 0.73. So sine of the angle is going to be 0.73. So now in your calculator, you can do shift and then sine to get sine to the -1, which is the opposite of sine. And we can do opposite sine to 0.73. So anti-sine 0.73 tells us that the angle of theta is going to be 46.9 degrees. So as Alison said, you can use 46.9 degrees here to figure out what this angle is going to be here. And then you can use this angle here with the area equals half AB sine C. So you can use this angle here with this side length and this side length to find out the area of the triangle. There's loads of really cool people who are coming on. And if you want to see those guys, then sign up to our schedule here or follow our socials here. Either way, you will find out what is coming up next. Thanks, everyone. And we will see you soon. Farewell all. Bye-bye.